Okay, this is lesson number 28 in Algebra 1, fractional parts of number and functional notation. Alright, both of these bits of this lesson are going to be pretty elementary, so I think that you'll not mind doing this lesson. First of all, when we take something like example 28.1 and we say 3/4 of what number, I'll use a hashtag to represent number, is 69. Alright, we've got a couple different parts here. We have this, 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 and this. So 5 different pieces here. And what we're going to do is we're going to use symbols in order to write an equation out. So that symbol is, we write the number, we always write the number. Of means times. What number means what are we looking for, so we'll put an X there, meaning we don't know what we're looking for yet. The word is always an equal sign, and we have 69. So I have an equation there. Of is times, is equal, what is your variable or your letter. So we have 3/4 x equals 69. Now in order to get rid of a number multiplied by a variable, we divide the entire thing by 3/4, and we divide the entire thing over here on the other side by 3/4. And when we divide, we get one number over another, and they're the same, so they disappear because 3/4 over 3/4 is 1. So we're left with x equals 69 over 3/4. And if you remember, when you have a fraction in the bottom, you flip it upside down and multiply it. So 69 is actually, if you want to write it as a fraction, is actually 69 over 1. So now I have two fractions that I'm multiplying. Alright, so one of the things that you can do, you can look and say, okay, 3 goes into itself once. 3 goes into 69 23 times. So now I've already reduced my fraction before I multiply it. So then I get 92 over 1. So my answer there is just 92. Alright, so if we look at another one, whoops, and example 28.2 says, what fraction of 40 is 24? What fraction, x, of times 40 is equals 24. There's my equation. So I'm going to flip these around and write it as 40x equals 24. Divide by 40. Divide by 40. Those cancel because 40 over 40 is 1. 24 over 40 reduces to 12 over 20. I just cut it in half. That continues to reduce to 6 over 10, and that can reduce even more to 3/5. What did it ask for? What fraction of 40 is 24? Alright, let's look at example 28.3. And again, some of this stuff might be really easy to you. That's okay. Just enjoy it being easy at this point. And let's do 28.3. It says 2 1/2 of 240 is what number? So 2 1/2 times 240 equals what number? So we're going to change that to an improper fraction. You always change it to an improper fraction first. Mixed numbers are kind of a pain to work with. And we'll make that into a fraction too, so that we're multiplying the 5 times the 240, which I've got a 2 here, and this is an even number, so I know 2 goes into it 120 times, so that reduces it right there. 5 times 120 is 600. So 2 1/2 of 240 is what number? 600. So if we take 2.5 of 240, we get 600. So you don't even have to really understand what they're asking for. You just need to know that of is times and is equal, and x is the number that you're looking for. All right, so let's jump into the second section of this. And the second section is called functional notation. We're not going to get into a lot of details for function. What they're doing is they're just going to show you how to write a function. And we'll get into what a function is later on. But right now, when you have a problem, and let's say that we have x plus 2. Okay, and I've taught this before, and you might have, Miss Tristan might have taught it this way before, where you've got this machine, and let's bring my machine down a little bit, and let's say we put a 3 in here. If I put a 3 in there, it's going to spit out for me what? It's going to spit out a 5. If I put a 6 in there, it's going to spit out an 8, because it's going to go through the function machine, and that x plus 2 is going to be the function that 6 plays. So what we're doing here is we're taking a number, putting it in here, using that equation there, and then it's going to spit out the answer. The answer that we put in here is the x. The answer that it spits out is the y. So we put in a number for x, and once we add 2 to it, it becomes a y. So what would they do is like this particular one would be y equals x plus 2. So no matter what number you put in here for x, so if we put in a 3 for x, what did we get for a y? We got a 5. When we put a 6 in here for x, what did we get out? We got out an 8. Okay, so when x is 3, y is 5. When x is 6, y is 8. But when you're doing functional notation, they quit using y's. They start using what are called functions. So let's say that we put, when x is 3, and we put that in there, and it's going to spit out a y value, we said, of 5, but we're not going to call it a y anymore. We're going to call it the function of x. So what they're saying is when this goes in here, the function of x plus 2, when x is 3, f of x is going to be 5. So all we're doing is replacing the y with that symbol right there, and it's called f of x. That's all it is. And sometimes they'll call it g of x, sometimes h of x. You can call it anything you want of x, any letter. But usually they call it f of x. Alright, so knowing that, they give you example 28.4, and it gives us x, whoa, my pen just kind of went psycho on me, x times x squared minus 3x, and they're telling me that x equals 2. So they're wanting to know the function. They're wanting to know what is called f of x. What happens to x if I put it in for this equation? So f of x squared minus 3x. So we're going to put 2 in there. Okay? So that's my f of x right there. That's my value I get out once I put this 2 in the function machine, and the function machine is going to make it do that. Okay, it's kind of like the pop machine out in the entryway. You put money in and it goes through some psycho thing like this, and then it spits out your f of x, your pop. Alright, so let's look at 28.5. If f of x equals x times x squared minus 3x, find f of 2. Alright, That's a real complicated way of saying we're going to take this number, and what is 2? Well, 2 is x. So whenever we see x, we're going to put that 2 in its place, and we're going to get our negative 4, like we did before. Alright, so nothing weird. It's just this is telling me what the x value is that I'm going to put in here, and then it's going to spit out an answer. So when x is 2, what is the function of 2? What's it going to spit out when I put 2 in there? That's all it's asking me to do. So in example 28.6, it gives me x squared. Gives me that. And it says, well, it says if x is 2, or if I write it, if f of x equals negative 2. I can write it that way. I'm just going to put negative 2 in there. So negative 2 is in there for x. Don't forget your parentheses. Okay, so this is 4. And this is negative 4 minus 1. 4 times negative 5. And that gives me negative 20. Now I didn't go through all the details of making that negative, positive, negative, and all that. You should know that by now. You should also know that because that's in the parenthesis, it's going to be a positive, and you're going to do the multiplication first, then subtract 1 from it. So don't forget your PEMDAS, doing it in the correct order, or you will, I promise you, get the wrong answer. Alright, one more. If g of x, okay, again, that's just your y value, equals x squared times 2x minus 1, and they want you to find g of negative 2. They just want you to take negative 2 and put it in for x. And this is just the exact same one we just did. And we get negative 20. Okay? Let's look at, well, let's call that good. That is lesson 28.